All right, so the remaining portion then, focusing on hair, is again, hair is a great forensic tool because it has two locations in which DNA can be obtained. The first being the root, which I'm going to again show you in the next picture. And if the root is absent and or damaged, we can pull some mitochondrial DNA in and along the actual follicle itself, or along the hair root, or along the hair length itself, if I can say. So again, the bulb is what is down in that dermal layer of the skin. It is connected and held in place by a connective tissue, and it forms this sort of sheathing. This is why also hair is painful if it is pulled on or ripped out, because it has a blood supply to it and nerves, which are very much close in proximity to that. So the outermost layer, if we were to look at a cross section, right, if I took this hair and just sort of chopped it in half and put it underneath, looked at it from the top down, that cuticle is the outermost protective layer of the actual hair itself. The cortex is the next innermost portion of the layer, and then we have the medulla, which is the central core. This varies by individual, and again, this is where we are turning to potentially pull some of that mitochondrial DNA. Now, again, the bulb, this portion down here, this is where it would contain a nucleus, and this is where we would be able to obtain just nuclear DNA. So hair can be used for a lot of different reasons. As I mentioned, it can be utilized for drugs. It can be utilized for cases of poisoning. We can sense things like methadone usage, arsenic, exposure to a poison, lead poisoning or lead levels, even the date rape drug, Rohypnol. But again, we have to be careful there because there is even a naturally occurring version of this. And so sometimes a byproduct of bacterial breakdown can cause false positives of Rohypnol. We can look at hair type. So again, what is the color of that individual's hair? Do they process it? Do they dye it? Again, can all lead us back to understanding location states, understanding, who saw them last potentially. Hair length can provide an overall timestamp, even simple things as water signature. This is a record. This is with you, right? This takes time to grow. And so this does provide a record and record keeping. New hairs are the ideal for forensic analysis because they have larger, more robust bulbs. So again, if you've ever had hair follicles that have fallen out and you see sort of like the end where it looks a little bit like it's like a white, gunk or something at the end, that's the hair bulb. That is, if it is a brand new hair that is kind of coming out, or shorter hair, baby hairs, right? That's sometimes what we call them. Those are ideal. It's got a nice, big, healthy, robust bulb, and it's going to have really good structure of its nucleus and DNA. As your hair ages and it falls out and is shed, the older or telegenic hairs, these fall out and they tend to have smaller bulbs. So PCR recovery may be a little bit challenging there. The other thing we really need to keep in mind is that keratin itself, the molecule structure that helps to create your hair, this needs to be completely dissolved in various types of chemicals to get to just the bulb or to that mitochondrial DNA, because keratin itself can actually interfere with the PCR protocol. It can interfere and not produce the correct signaling. So again, just things to consider as far as this, maybe I'm asking you questions around just the overall of this. How can hair be utilized in criminal investigations, right? Give me 2 out of the 6 different things we've talked about. True or false, keratin can interfere with PCR protocols. How can hair color provide feedback in forensic criminal investigations? So again, just thinking through some of the types of questions here. How can hair be utilized? So again, hair can even obtain and take on explosives. And what do I mean by that? So again, explosives they're a chemical. They're going to release, they're going to, whether they are the powder that's going into the chemical reaction to further ignite, or, during the explosion itself, being within close proximity, right? You know, individuals who were maybe blocks and blocks away from 9/11, when that had happened, when that explosion took place and, coming down, all of that debris went into the air. That creates a signature in a lot of those people's hairs. And so, we can indicate things like the type of explosive that was maybe utilized. This can give us forensic detailing around bomb cases, but it can also lead back to suspects. So there is an example of a woman out of Fort Worth, Texas. Her name was Julia Poff, and she sent mail bombs to both President Barack Obama at the time and Governor Greg Abbott. And it was traced back to her through her cat hair that was actually found in the box. So there was cat hair found once they identified that it was animal and not human. They were able to obtain some of the trace signatures of the chemicals, which of course, that would have been left over from the mail bomb itself. But also then it started the hunt of where could this cat have come from? So, white cat of a certain type of breed, certain type of analysis, you start to localize that down further and further and further. And I mean, again, it isn't to say that all bombing cases are not going to be taken seriously, especially when we're talking about interfering inside of a government agency as of the mail, the US postal system, that alone is going to cause red flags. But if you're sending them to, very, very high powerful people, you're getting all hands on deck on that one. So yes, it was traced back through a cat hair that was found through the box. So the last portion of this chapter focuses on bone analysis and teeth analysis. And so again, if we are looking at types of tissues, we can look at things that can make up and filter through our bones. And again, this is things like osteology. And so osteology especially will come back into play when we talk about wounds and wound indication and wound markings. But the human body as a full adult has 206 skeletal bones. And all of these bones can give us a feedback insight into age, the overall sex of an individual, potential ancestry, and even if there is trauma. And again, we will come back to that when we talk about weapons and wounds in the next chapter. So as I mentioned, osteology, we can look at the shape and arrangement of bones. We can look at, are they long bones? Are they short, irregular, or flat bones? These are the four major types of bone structures that we can look at inside the body. The smallest of your bones in your body being in your inner ear, your incus, your malleus, and your stapes. To looking at some of the largest bones in your body, which are your femur. And again, coming back, is it animal? Is it human? That's one of our very first questions we asked in question 1 or in chapter 1. Looking at this, right? First eye pass, if I'm looking at a baboon femur versus a human femur, to an untrained eye, that's going to look very similar. And so studying the characteristics, the ridge lines of these, the overall makeup, what is the chemical analysis? What is the organic chemistry and makeup of this? That is important as well, because it's going to show different stress fractures for the different type of environment that this particular animal, us included as being an animal, are utilizing that particular bone. So skull is another place that we can actually identify for male versus female. It also can tell us a little bit about age. So for female skulls, they tend to be more rounded. They come down into more of a rounded surface in the front here. They have a smooth forehead and a little bit more of a rounded jaw at the bottom versus more of a squared jaw for males, and a more pronounced bridge line, right? So again, a brown line, I should, sorry. So again, looking at the angle here, much more acute in the male, And again, almost more closer to almost a 90 degree as far as the squaring of the jaw. Is this always perfect? No, absolutely not, right? These are just metrics that can tell us. Skull identification as far as the sutures. So if again we are unaware, right, as you are coming into this world, if you were born the vaginal versus cesarean way, right, your head, you know, we know that there's a soft spot on the baby's skull. Why is that there? Well, it's because as you're coming down, right, if you're going through the vaginal opening, that skull needs to fold over so that it can come out. And so you need that little bit of wiggle room so that when the baby does come back out, right, now those different plates of the skull can start to form back into a correct alignment. And sometimes we see things like babies get born with cone heads, right? Usually that tends to go down as gravity starts to take its position. Or we can see, unfortunately, there are, you know, kiddos that sometimes get that sort of flat head where they have to wear just the little helmet, right? It's specialized and it helps to form and pull the skull to where it needs to be. That's a beautiful thing that we can do this because it helps for full development of the brain appropriately. Usually it's a very small time. Babies look so darn cute in them anyways. Maybe it's even like a little bit of a safety net for your kiddo too, you know? But the fact of the matter is that this is allowable and, you know, better to do it then because kids are malleable. Things are not set yet. So really, as far as your skull is concerned, these areas that have little tiny gaps to allow for many different things, this is not fully closed off until almost the halfway, if not more, of your life. So by the age 30, the suture at the very back of the skull is going to start to close. By about age 32 to 35, the suture running across the top portion of the back of the skull begins to close. And really, it's not until about 50 that the suture that runs from side to side over the top portion of the skull will begin to close. So your skull is not completely fused until almost halfway of your life is over. You know, God willing, we all live to at least 100. So children's bones are very uniquely different because they have to grow, right? And so that is important. And so what we see is that inside of our bones, it can tell us an age of an individual. So if we obtain a bone, we are trying to identify age. We will look for what is called the epiphyseal plate. The epiphyseal plate is where you will push out new osteocytes and new bone. And eventually, as you grow and grow and grow, that cartilage gets smaller and smaller and smaller and smaller until you have finished and completed your growth. You are at the height you are now going to be, and that epiphyseal plate closes off, right? So the epiphyseal line will eventually disappear. So if it's very wide in the bone that we tend to find, that will indicate that we are looking at a younger individual. So at birth, why kids are pretty malleable is because they actually start with really 450 bones that need to eventually be fused together through this process. Over time, that fusing of those bones together will bring us down to about 206 in the adult. Again, this can help us to tell approximation of age. The last couple of things here as it relates to bones and sort of gender identification, we can look at the pelvis and the femur. So pelvis for females, obviously, you know, naturally designed for childbirth, so pelvic girdle is wider. It sits at a wider angle to be able to birth and hold a child. The female pelvis is wider than that 90-degree angle versus the male. And for males, the femur tends to be thicker because musculature tends to be bigger in males. And what we see because of that wide pelvic angle in females, the femur actually sits on a larger angle versus the male. It's going to be more up of an up and down, more of a straight, because again, they're not preparing for birth. So this leads to the last little bits of this chapter, which is dentistry, right? Odontology. And so we know that teeth are extremely resistant to decay due to the very, important material of dentin and enamel, that they get that nice, beautiful sheen on the outside, but it's very, very resistant to breaking down, even decades and hundreds, millennia later can still be around. So they are extremely resistant to decay, and they can survive extreme conditions. Even if we are talking about things like cremating, sometimes teeth can still even, survive that as well. So DNA survives in the compact bone of what teeth are residing in, and with inside of the inner dentin layer of teeth. So again, makes a beautiful place to be able to go and obtain that DNA. We also know that we lose teeth and we replace them with permanent. So if we are losing something, we can call this deciduous. So again, forests that go through the losing of, or trees that go through losing of their leaves to replenish them, we call those deciduous trees. They shed and regenerate. And so if you did not know this, inside of a child's skull, right, as it is taking in nutrients and all those things, it's actually forming the teeth that eventually are going to be pushed up and out to replace your baby teeth. Do you want better? Sometimes individuals that have things like their wisdom teeth removed, they can regenerate. And there is a very small subset of the population that can actually grow new wisdom teeth. Kind of freaky. So as we had mentioned in our last chapter, especially around molecular aspects that we can identify, the ameliogenin test comes straight out of the teeth. So again, the ameliogenin is a portion that is inside of the formation of the inner workings of the tooth near the root and the dentin component. And that is the location that we are pulling from to help us to identify sex. Teeth can also tell us a lot. I just give you one case example. We are going to move into wounds, and we are going to talk about bite marks especially. But teeth have unique patterns. And, sometimes people have extremely unique patterns. And in fact, Ted Bundy was one of them. Ted Bundy had a very, very unique bite pattern. This was his teeth here. And actually it was, this was part of the reason that helped to kind of identify it, after he was caught, and, in an identification of his involvement in some of his victims, because he would bite his victims. And so again, looking at that teeth distribution, and this is a sort of model and rendering of his teeth, right? He had this sort of unique pattern and distribution to it. And so again, these are things we can turn to, even outside of that DNA component, right? We can look at this as sort of an identifier. So here's a summary of most of what we went through. We didn't talk too much about nails, but overall we have touched briefly upon each one of these things. So go through, review, take a look, check out. I will also have some additional things in at the end for you to just kind of move through and study. So that is it. That is everything. Hopefully you are safe and warm, and I will see you on Monday.